Mechanical engineering is known to be one of the broadest disciplines, but what do you learn in Mechanical Engineering University that actually makes it this way? Well, today we're going to explore all of the general mechanical engineering subjects and courses that really make this discipline one of the broadest disciplines in engineering. I'll also go over some of the applications of each of the courses to really get an understanding of how you can see all the things that we're learning in your everyday life. Okay, so first we've got fluids. Fluids is basically learning how the fluids around us, like air and water, work when they're moving and when they're not moving. I really like these type of courses, especially like the aerodynamic side of it, because of their direct applications in your everyday life. It can be from water coming out of your faucet at your home to the aerodynamics of the Bugatti bolide using golf ball physics and golf ball aerodynamics, stuff like that. So to list a few of the things that you'll learn, you're going to be learning about laminar flow, turbulent flow, aerodynamics, Bernoulli's principle, steady state, vector fields, pipe flow, control volumes, and a whole bunch of other stuff. So next you've got dynamics and mechanics. And this is where you're going to be taking some of that physics high school knowledge and applying it into real world scenarios and basically leveling up that knowledge with higher level math and way more other stuff. This is where you're going to be reminded about Newton's laws, motion, acceleration, velocity, kinetics, kinematics, dynamics. Basically think about it as if I apply forces to this object, where will it go? What will it look like after this amount of time has passed? Or if I throw something up in the air, how long will it stay up in the air? Stuff like that, just understanding how motion really works. And that's essentially why it's so important in mechanical engineering, because you have so much power in understanding where something will be, where something will end up at a certain point in time. This course is cool because you get to analyze and predict what the future will look like, basically. So some of the things that you'll learn in these kind of courses are the types of acceleration, velocities, conservation of energy, kinematics, kinetics, all that force analysis, rigid body motion, dynamics of mechanical mechanisms, just to name a few. So now you've got your thermodynamics and kind of your introduction to chemical engineering. So when I talk about mechanical engineering being the broadest discipline, this is where it can kind of scoop a little bit of that chemical engineering experience. Thermodynamics, if I could simply put it, is how can we use heat? That's the simplest explanation for it. So because there's that little chemical engineering aspect of it, you're going to be learning a lot about processes in these kind of courses. So kind of maybe cycle processes, stuff like that. So these kinds of courses are really cool because you'll get to understand how like an internal combustion engine works or how a turbojet works. So this is where you're going to get a lot of that work kind of stuff. How are we going to make stuff move? How are we going to generate work from heat, or how are we going to use work to take away heat? In my university, there's an entire course on just heat transfer. So this is stuff like from heat conduction, convection, heat through walls, heat sinks, and so much more. There is so much to learn about in thermodynamics and heat transfer. It's an incredibly big part of mechanical engineering. So some items that you're going to be learning in these kind of courses are going to be internal combustion engines, heat engines, AC, refrigeration, entropy, work, thermodynamic cycles, compressors, turbines, just to name a few. So next up, you've got your project and design courses. And this is where you're going to be put into a group. And in the beginning of the semester, you're going to be given a problem statement by your professor. And throughout the entire semester, you and your group will have to use your engineering knowledge to create a solution to this problem. And this is going to stem from the documentation side to the design, the CAD rendering, and then the execution or manufacturing of the actual design or the presentation. So personally, I found that these types of courses are really fun, but incredibly time consuming. There's just so much that goes into it, from managing the team, you know, those meetings, to creating a design, going through your preliminary steps, developing the design in SolidWorks, and actually manufacturing the product. It's a huge course. And this is where you're going to be learning the most, honestly. It's also good to note that in these types of courses, you're going to be learning about the basics of mechanical engineering, from what types of gears are there, what types of bearings are there, motors, all that kind of stuff, just to really supplement that knowledge that you'll need to create those final projects, those team group projects. Think about these kind of courses like, okay, we taught you so much about engineering, now let's go ahead and make some sense out of it and really apply it and actually make something. That's why it's so cool. So alongside these project courses in mechanical engineering are your design courses. And this is where you use a software like SolidWorks to really create a part or assembly and take that part or assembly and create your engineering drawings from there. So this is really supplementary to all of those project courses because you're going to be applying all of that knowledge directly to the design of those project courses. So yeah, they kind of go hand in hand, but the design courses, again, also really time consuming because they're just so much to do with those engineering drawings and creating those parts. And another part of the design and project courses is learning about the types of manufacturing as well. So there's just so much to learn about in these project and design courses. That's kind of why I put them together, because they kind of go hand in hand. So next up, you've got your mechanical measurements course. And this kind of course is not the most fun course, but because it's based on how engineers and mechanical engineers basically measure anything like length or speed or pressure, it becomes a foundational skill for all engineers. At the end of the day, let's say that you're trying to measure a speed with like a radar, like a radar gun. Now, how can we understand all of the components that make up that radar gun and see what are the errors associated with the signals and electrical circuitry or whatever is going on inside of the radar gun to see what is making it deviate from reality? So if I measure a car at 100 kilometers per hour, but it's actually going 98, there is some error associated with my radar gun that needs to be accounted for, essentially. So all of this is mechanical measurements, understanding how engineers can understand how measurements are taken. This is also where you'll get a little taste of electrical engineering as well, with signals, amplification, the different types of circuits, logical gates, binary, just to name a few. Now, in terms of coding, in mechanical engineering, there's not a ton of it, but we do use MATLAB quite a bit, especially in one of our courses, numerical methods, where we kind of understand how to take all of our calculus that we learned, all that handwritten calculus, all that data approximation, all of that we've been doing throughout the last few years by hand, and how to use code to bypass all of those hand calculations. That's where numerical methods is. So that being said, if you want to learn how to code as a mechanical engineering student, I 100% recommend that you just go out there into like online, whatever resources that you can find to actually understand how to code using whatever programming language that you want to learn. Because in mechanical engineering university, you're not going to be coding a ton. You're not going to be learning how to code a ton. Okay, so one of the big ones, math. So math in mechanical engineering, if you're asking how much math is there in engineering, I have to say that engineering itself is just the application of science and math. That's essentially what engineering is. Mechanical engineering is the same thing. It has so much math into it. Everything is math. Everything in mechanical engineering, everything in mechanical engineering is math. That's gonna apply to your other engineering disciplines as well. Engineering is just math. It's all math. It's all math and science. That's all it is. Honestly, because everything is math, it just matters what context you use depending on the course. If you want to know how much math there is in mechanical engineering, the answer is yes. So first, you're going to be taking your calculus courses just to get an understanding of, derivatives and integrals, all that kind of stuff, all that jazz. And then you're going to be using linear algebra as well throughout some of your courses, creating matrices, understanding 2D and 3D space, understanding vectors, and basically all of that as well, because calculus and linear algebra will come together a lot in mechanical engineering to really understand all of the concepts in each of the subjects. Now, alongside those two courses is differential equations, which is basically how calculus models nature. Just giving the example of a bar, and imagine you have that bar and you apply a heat at one end of it. Now, what is the temperature gradient of that bar going to look like? Or if you have a drum, if I hit that drum, what's going to happen to the shape of the drum? And how can we model each of these things using math? That's differential equations. And there's so much power in understanding how to use math to model nature, which is why in mechanical engineering, we have to take one extra math course compared to the other engineering disciplines to understand further about how things move in actual nature. So that's the power of differential equations and why you really need more of it in mechanical engineering. So basically, the common theme throughout almost all of your courses in mechanical engineering and most other engineering disciplines is calculus, linear algebra, and differential equations. Those are the big three. Now you have materials, and this is where you'll take some of that materials engineering and get to absorb that as well as a mechanical engineering student. Now this is where you're going to be taking that high school chemistry knowledge that you've previously had and really applying it into how do we choose a material for the job. That's essentially it. Now for an example, let's say that you're trying to make a basketball. How do we know what material to make the basketball out of? Or maybe you're trying to make a sword. How do we know what metal to use for that sword? Stuff like that. And this goes from the macro scale to the nano and atomic scale, which is where that high school chemistry really comes from. So understanding that materials behave in this way because of these atomic properties or these nanoscale properties, whatever. Also in this course, you'll learn how to make a material better suited for the job, such as using processes like annealing or cold working. Another area in materials engineering is failure analysis, like when materials break, essentially. Now, this is really cool because this is kind of like you becoming a detective. So let's say that you had a metal rod that broke, okay? And based on how it broke, you can understand as someone who understands materials, how did it break? Did it break under, let's say, ductile or brittle failure? And how can we better design future metal rods such that this won't happen again? That's basically what you learn in materials engineering. So next is electrical engineering. And here you're going to be learning more about the basic circuit theory, like learning about resistors, capacitors, inductors, DC and AC electricity, power, that kind of stuff. And really understanding how to read a circuit diagram and how to analyze it mathematically. Now, although it's pretty basic level electrical engineering, don't be fooled because the math that goes behind analyzing these circuits can get quite comprehensive and quite long. So yeah, there's just a whole nother world of electrical engineering, especially when you introduce imaginary numbers. This will probably be the only course where you'll really use imaginary numbers because electrical engineers need them. That's how weird it is. They need imaginary numbers. They need to define the square root of -1 for their calculations. I don't know, don't ask me. Don't ask me what. So next up, you've got statistics. And honestly, this is one of the courses that almost every university student takes and everyone always complains about it. The reason why I think a lot of students don't particularly like this course is because of all the math that you have to come up with given a problem and understanding probability and stuff like that. It kind of gets a little bit weird, but it is still super important, especially in the science realm and understanding how science really works. a lot of the time we work in the theoretical world where everything is, in theory, ideal, right? But if we actually use statistics, we can take math and our real world experiences to understand our world more directly in non-ideal circumstances. And we do all of this through probability. So that's how statistics works. Using probability to understand science more. So now we've got civil engineering, and oh my days, I hate civil engineering so much. But now civil engineering is where you get to open up a whole new world where things don't move when the sum of forces equals 0. That's basically civil engineering. So here you're going to learn about things like I-beams and how when we apply forces onto things that are not moving, how do they bend? How do they smile at you? Or how do we apply forces or moments or torques to make sure that something doesn't move? That's basically the realm of civil engineering. Now, the reason why this is so important in mechanical engineering when a lot of the time things are moving is because you get to understand aspects like stress, strain, deformation, forces, moment, which are way easier to understand when things just aren't moving. Congratulations, Civi. That is the one great thing about you guys, that things aren't moving, so it makes things a lot simpler. Let's say that. Okay, let's say that. Also, you'll be able to understand through those forces and stresses more about your materials. So how do we ensure that this material isn't subjected to the amount of stress such that it fails, right? So this is where you're going to be learning a little bit more about your materials engineering and just when forces and stresses are applied to an object that's not moving. This is civil engineering. Finally, you've got your electives, where basically you get to personalize your own engineering experience. This will be the only time where you get to actually control your courses. So make sure to definitely take advantage of that. And if you really understand what kind of engineer that you want to become in the future, this is going to be a great time to really start honing into those skills. So maybe you want to go more into aerodynamics or project management, or maybe entrepreneurship. Stuff like that. This is where you get to personalize your engineering experience and gain all that information and knowledge that you need to excel in the industry that you want to take on in the future. And through this, because not everyone is learning the same electives, this is where you're going to be able to really separate yourself from the crowd and really develop your own knowledge and skills in your own engineering journey. It's also good to note that in engineering in general, throughout all disciplines, you'll be taking courses like financial management or engineering safety, engineering ethics, those kinds of courses as well. So not necessarily mechanical engineering, but still in your degree. So for example, in your financial management class, you'll be learning about stuff like income statements, balance sheets, mortgages, understanding the time value of money, just understanding finance and how finance works in engineering and in the companies that engineers work in. And this is also nice because you get to learn a little bit about the personal finance side of it as well, which is also nice because not a lot of schools teach you about personal finance. And as engineers, it's always nice to know what to do with all that cash that you're going to be getting, all that money. Now, although I've shown you all the things that mechanical engineering students learn, you may be wondering, what does each engineering discipline even do? Well, I made a video right here interviewing every engineering discipline in my university for you to get a way better understanding of what each engineering degree even does. And if you find value in this video, make sure to hit that like and hit that subscribe for more engineering related content in the future. Thank you so much for watching. Farewell, my G. Farewell. Farewell. Farewell.